Hi everyone, welcome back to Infinite Math Help Squared. We have our last part of transformations, dilations. We're going to use transformations again when we talk about congruency and similarity, but as far as covering transformations, constructing them, identifying them, this is the last one. So let's get started. I want to start by going over what a dilation is. In another video, when we first started talking about transformations, I mentioned pupils dilating. They can get smaller or they can get larger, depending on how much light the eye is exposed to. Over here, we're going to take the triangle and we're going to apply a scale factor. I'm going to link this in the description of the video so that you can play around with it as well. But right now, the scale factor is 1. So I'm looking at the original and I'm looking at the image on top of it. That's why it says A prime, B prime, C prime. But what happens if I increase the scale factor? I'm consistently making my pre-image larger and larger and larger until I can't go anymore, according to the applet. This is the largest that I can make my image. Okay, so I'm enlarging the blue triangle. Okay, what happens? Let's reset and get back on top. So this is again scale factor of 1, right? Anytime you multiply by 1, you're left with itself, the item. Okay, what if I multiply by something smaller though? Right? You can see it getting tinier and tinier and tinier. It's also doing what? Hopefully, we didn't talk about what you need for dilations. Obviously, we need a scale factor and we need something to dilate, but we also need a center. P here is acting as our center. And what you notice is that as the smaller the scale factor, the closer the figure is getting to the center. So the distance is closing. That's not a coincidence. Because when we talked in transformations, we have talked about equidistant, right? And using, let's say for rotations, we used a center of rotation and we had to pass through that center to get to the image. Well, with dilations, we're going to do something similar. So just remember that when the scale factor is less than 1, the figure is getting smaller, but if the scale factor is greater than 1, the figure is getting larger. So we say that dilations enlarge or they shrink. That's what we say dilations do. Okay, let's start constructing. And in the constructing, you would hopefully be able to just do the reverse and identify. Let's say that I have triangle here, ABC. It's, notice A is at the origin. So we said center, and we need scale factor, right? So if my center is 0, 0, and my scale factor, I will make 2. Let's just make sure that that's legible for you. So center is 0, 0, scale factor is 2. Let's apply this to triangle ABC to dilate it. And then let's go with the green like we did in the beginning per the applet. Okay, so this means that the distance from the center is going to double, right? We talked about distance. I'm going to look at the coordinates with you, as usual, to search for patterns. But remember what we just said when we were looking at the applet. We're getting either closer to the center or farther away. So let's examine it in reference to our center. So right now, the length here of the height of the triangle is 2 units. This is the center here at the origin. So if I'm doubling the distance, if I'm getting farther away from the origin, double 2 to get a total of 4. So my new triangle is going to also start here at A at the origin. This will be my A prime, and I will go up to 4 so that my distance is doubled. This is the B prime. Okay, how about the base? The base from the center is also 2 units, and I'm doubling that. So that means I have to go to 4 again, and here is C prime. And now let's close it. There we go. It's closed. And now you have a dilated triangle A prime, B prime, C prime. It is a dilated image of triangle ABC. Now I promised we would look at the coordinates. So A was our center, and as you've seen in the past, the center is not changing if a point is the center, right? So A is 0, 0, and A prime is also 0, 0. Let's take a look at B and B prime. B used to be 0, 2. B prime is 0, 4. And then there is C and C prime. C is 2, 0. And C prime is 4, 0. Okay, look for a pattern. Obviously, don't mess around with the center because center is fixated again. But if you compare from B to B prime and C to C prime, you should notice something. You should notice B times 2, C times 2 gives you the prime versions, right? And what was our scale factor? 2. So you don't have to do this in terms of counting the distance from the center. If you don't want to, you can simply use the coordinates. Just multiply by your scale factor. Let's take a look at 1 where it's not centered at the origin. But we're still going to use the origin as a center. So let me notate this. This is going to be our center of dilation. So now our center is still 0, 0, but the figure is not there. And let's see how that affects it. Still triangle ABC, and let's keep the scale factor the same since I moved the triangle away from the origin. Okay, so I'm going to do it in terms of distance again, just for consistency, and then we'll look at the coordinates. Okay, so let's take a look at what is the distance from A to the center. Right now, it would be 1 unit in height and 2 units laterally. So we want to increase that by 2. We want to double the distance. So if the distance used to be 1 up, now it has to be 2 up. So that's 2 up instead of the 1 up. And then it has to be 4 instead of 2. So let's put that, erase that because you have to do both at the same time. So double that, and then, so this is our A prime now. Okay, let's take a look at B. 1, 2, 3, right? Your height is 3. If you double the distance, it will be up to 6. So that's over here. But let's take a look at laterally. Laterally, I'm at 4, which means I have to go all the way over here to 8. I have to double this distance. Double the lateral distance, double the height. So this brings me to 8 and then 6. Now, that's kind of doing it with the coordinates instead of by steps. But I haven't been writing the coordinates down. I've just been counting the units visually on the graph. How about C? C is only 1 unit away from the x-axis, a lot like A. So that means that they will be close together on the same plane here. And then let's see about laterally is 4, just like B. So that means it's going to have to be right here, right? So double the height, double the distance. Laterally. Okay, so let's put that right here. This is, oh, C prime, and then sketch. Okay, triangle A prime, B prime, C prime is a dilation of triangle ABC. It was made by a scale factor of 2 and centered at the origin. So I think that pretty much covers it for dilations, basically, right? We could take a look at the coordinates if you'd like, real quick. A used to be 2, 1. Let's just take a look at this. This one is 4, 2. Are they both a multiple of 2, right? So 2 times 2 is 4, and 1 times 2 is 2. Check. So both strategies worked again, even though the figure was not centered at the origin and the center of dilation was not on the figure. Okay? If you guys have any questions, leave them in the comments below, or check out Infinite Math Help Squared's Twitter and DM me or share a picture of a problem. Thank you.